Welcome to our statistics course. Statistics? If this is statistics, then what's all this stuff about fractions, decimals, and percents? Well, I can explain. You see, statistics is all about probabilities. Give me my pen here. Okay, probabilities. And probabilities are ratios of chances. How many chances to win, how many chances to lose. You have to think about these things. And you make ratios out of them. And ratios can often, and are often, expressed as fractions, decimals, and percents. And we will use all three forms throughout this course. So it makes sense then that we'll just start here, have a nice lecture where we revisit the fundamentals of fractions, decimals, percents, and in particular how to convert among the three forms. So I got 4 pages of note here. It's not that big of a review, but it's worth doing. So let's start here. What's a fraction? Well, people say all kinds of things about what's a fraction. They usually mention pizza and stuff like that. Here's the answer I'm kind of looking for. It's a ratio, right? It's a particular kind of ratio. It's a ratio where you have a part and a whole. You put the part over the whole and form a ratio that way. Now, what's important here is that you have to be counting equal-sized portions. That is oh so important. And I'll make that point right here. You see that? Does that look like a third to you? Let's get a different color going just so we don't get too overlapped here. Does that look like a third to you? This here? This little part? Well, there's one part that's shaded, right? And then the whole has, looks like 3 parts. But wait a second, they're not equal-sized parts, and so we're breaking a law there. And so it's not 1/3, actually. It's really not. So what you got to do to fix this is you have to first take a look at this pizza pie or whatever it is and think in terms of, how can I slice this so that all the pieces are the same? And actually, in this case, it's an easy fix. You just put an extra slice right about there. And now you can say, these are all equal-sized pieces. Cool, man. And so I've got 1 orange, 4 total. That is the proper fraction right there. That is a 1/4 or a 1/4, not a 1/3. If you wanted a 1/3, here's what a 1/3 looks like. You'd have to break it into 3 equal pieces. So go to like the 8 o'clock and the 4 o'clock positions and take one of those. That would be a 1/3, right? Hey, it's like a peace sign, sort of. That would be a 1/3, but that was a 1/4. Okay, cool. So, ready for a first drill? What's that? What do we have here? What fraction is shaded orange there? Now, if you said 6/8, you would be correct, right? Because look, they're all equal-sized pieces. I got 1, 2, 3, 4, 5, 6 in the part that's orange, 7, 8 in the whole thing, so it's a 6 out of 8. But I know what you're thinking. You're thinking, no, man, that's really 3/4, ain't it? I mean, come on, that's 3/4. And of course it's 3/4 because it's 3/4 of the way around the clock face or whatever. This is called reducing, and this is something you always want to do. If you don't reduce your fractions, you always lose at least a point. Okay, so I'm going to write this down. In fact, I'm going to get like fuchsia about it, or whatever this color is. We want to reduce our fractions whenever possible. It's not always possible, but whenever, how do you spell that? Possible. Okay, please keep that in mind on pain of losing points. So how did we reduce? Well, one way to look at it is if you just kind of take a piece of tape those two together, so that becomes one piece, right? And then you tape these two together, so that becomes one piece, and then you tape these two together, and then you tape these two together. In other words, you're taking 2 at a time is what you're doing. And so then you say, oh, now I've only got 1, 2, 3, 4 pieces. 3 of them are orange. The 4th is not. It's 3 out of 4. Or in math class, we typically talk about canceling 2's, which is not the most satisfying explanation. Oh, yeah, you're canceling 2's. Well, it's kind of like a regrouping thing, really. You're taking these 6 pieces and taking 2 at a time. There's a piece, there's a piece, there's a piece. You're taking these 8 pieces, and you're also taking 2 at a time. And when you take 2 at a time, you can take 2 3 times. You can take 2 of these 4 times, and that's how you're getting your 3/4. So anyway, I get excited by things like that. So if you like, you can think of it that way. If you really like the rule better, use the rule, cancel 2's. The point is, please reduce your fractions whenever possible. So the main point that I was making here is fractions are the ratio of part over whole, and make sure that you're counting equal-sized portions. And then make sure you reduce. Okay, here's a slight bit of a challenge here. The question I have for you is, you see that orange part? That's like a little rectangle here, right? And then you see this big rectangle here, right? And it's kind of cut up in a weird way. But I want you to estimate what fraction is this? What fraction of the box is that? Okay, you're on Jeopardy. You're trying to win the big points. How do you do this? Well, first of all, it's not 1/4, right? Certainly not 1/4. I hope you've got that point by now. It's not 1/4 because those are not 4 equal-sized pieces. If you can see that it's 1/6, pat yourself on the back. You're on your way. How did I get 1/6? Well, first thing I did is I said, well, here's a piece, and I'd like to know how big that is. And what I'd like to do is take that big rectangle and sort of cut it into equal-sized pieces. And since I want to know how big this piece is, I might as well just kind of slide it over here and make another piece, right? So this piece is the same. I can also slide it to the right. That looks the same, right? I mean, we're making assumptions that, you know, that these dimensions really are as exact as they look or whatever. Same. And then if you kind of glue these two together, then this is the same. And if you kind of glue these two together, then this is the same. And so you notice we've got 1, 2, 3, 4, 5, 6 equal pieces all together, 6 in the whole enchilada, and 1 was shaded orange, 1 was shaded orange, and so the fraction is 1 out of 6. Pretty cool, huh? What about that one? You got a nice challenge there for you. What fraction of that is shaded orange? Let's do a different color. Do. Okay, so I hope you got, what did I get? I'm not even going to look at my answer. I want to figure this out from scratch. Okay, so I'm going to go back to the old idea that this is 1/6, right? We knew that that was a 1/6, and I can do this again, right? So that's the same, that's the same, that's the same, that's the same. So this part in here is a 1/6. And then if I think of kind of gluing these two together, can you see how like this is like exactly half of this this little rectangle over here? And if I kind of took this piece out and glued it right there, I'd have another 1/6. So I'd have 2/6. By the way, reduce. Cancel 2's if you like. It's 1/3. That orange part is 1/3 of this whole triangle. So that's one way you can get the answer. There's always more than one way to get the answer, and that's why it's healthy to play around when you're in math class. Play around with stuff, because the answer that you see is usually going to be the best for you. But here's another thing I could do. Is I could say, well, you know what? Let's just deal with these triangles. I'll cut that into triangles. I'll make everything into these little triangles. So I got all these little triangles. Now these are kind of backwards, but that's fine. It's all the same size triangles, right? Okay, cool. 1, 2, 3, 4. I got 4 triangles that are orange out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 out of 12. Notice if you divide by 4 top and bottom, you get the same thing, 1/3. So there's multiple ways to do this stuff. But I hope I'm drilling this point in that you need to have, what's a good highlight color? Maybe that one. You need to have equal size portions, and then you can count up how many are shaded orange or whatever, what's in the part, how many in the whole thing, which is the part and the rest of it, the whole thing, and then you make a ratio. Part over whole is called a fraction. And pretty soon we're going to call that a probability, but that's not till Friday or something. All right, next page. 1 page down, 3 to go. What's a decimal? So just ask yourself, you know, a lot of times, like I do this a lot. I go through 40 years of life and then I go, what is a, you know, whatever, ask anything. And then it's amazing how sometimes something that you really, really, really know, You can't put it into words because you've never put it into words for 40 years. Well, what's a decimal? Can you put that into words? What's a decimal? Well, by the way, you might want to chew on this a little bit too. Often people call this page not decimals, but decimal fractions. Look at that. Decimal fractions. Have you ever heard that phrase before? Decimal fractions. So the point they're trying to make is that decimals are really a special form of fractions. They're still fractions. They're still going to be parts over whole. What's different? Well, what's different is let's put it this way. We always work with tenths. So in other words, instead of saying, hey, I'm going to make a fraction with a 3 on the bottom. No, you're not. You're in decimal land. You're not going to put a 3 on the bottom of your fraction. You're not going to put a 4. You're not going to put a 5. You're going to put a 10. You put a 10 on the bottom of your fraction. So always work with tenths. So this, for example, this 0.2 means 2/10. That's what it means. So this box here, I've cut it into 10 equal strips. You can verify if you like. What would 0.2 mean? It would mean basically shade in 2 of these strips. Doesn't matter which 2 particularly, but I'll just shade these 2 in. And that shaded portion there represents 2/10 of the whole square there. Okay, so that's how they work. So the whole idea of using tenths, of course, is because then you can use place value. Because place value, going back the other way, if you don't have a decimal, you've got the ones, you've got the tens, you get the hundreds, you get the thousands. Well, somebody said, why don't we do the same thing on the other side? And so these are the tenths. What am I saying here? I'm saying tenths. Make sure you get that TH in there. Make sure so everybody hears it. That's tenths place. So we always work with tenths. Even if, even if it means we have to cut the tenths. You need smaller pieces? Well, you cut the tenths into tenths. Not tenths. Tenths. I'm feeling tenths. No, tenths. Have to cut the tenths into tenths. 10 equal pieces. So that would be called hundredth, by the way. A tenth of a tenth is a hundredth. Comma. So here's an example of 2 in the hundredths place. Remember, it's just like place value. The other way you'd go to tens place, and then you'd have a hundreds place. Well, here we start with the tenths place. So then we move to the hundredths place. The second place after the decimal is the hundredths place. So over here, we only had 10 strips. How are you supposed to look at hundredths if you have 10 strips? The answer is you take every single one of those strips and you cut it this way into 10 pieces, so that now you've got, every tenth has 10 pieces. You've got 100 pieces here in the whole. And I just want to shade 2 of them. Doesn't matter which 2. Maybe I'll go this way. There. I shaded 2 of my hundredths. And that's what a 0.02 looks like on a little diagram. So if the big square was a sheet cake, that would be 0.02 sheet cakes right there. That shaded part right there. So to continue on this definition up here, we always work with tenths, even if it means we have to cut the tenths into tenths, and so on. Even if we have to cut the hundredths into tenths. So in this one here, I didn't actually do it with the boxes, but you can kind of see that that's kind of what we're being demanded of here. This is in the, what's the place value? Well, that would be tenths, that would be hundredths, that would be thousandths. I feel like I'm blowing up a balloon here. That would be the thousandths place. How would you show 2 in the thousandths place? Well, you can't color in one of these because that's already a hundredth. That would be 0.01 right there. Right? So you have to cut that into 10 equal pieces. So I don't think I can actually do that with this thick of a pen. So I'm just gonna say, imagine cutting this hundredth square, whatever you want to call it. Imagine cutting this hundredth square into 10 equal pieces. You always cut into 10 equal pieces, into 10 equal slices, whatever you want to call it. and shading 2 of them. What would that look like? I don't know. It might look a little bit like this or something. It's going to be hard to do that accurately, but maybe something like that. Here's the idea. You have to imagine that you can, and if you really wanted to, if you had a 4th decimal place like here, you'd have to take each of these little tenths and cut those into 10 equal pieces, and it quickly gets microscopic, right? That's because, well, we know that. If you have a really long decimal, it's microscopic, man. So now I'm going to put this all together with this example, 0.363. Let's get a different color for this one. So we have tenths, 3 of them. We also have hundredths, 6 of those. And then we also have thousandths, 3 of those. So if I want to shade in 3 tenths, well, that's going to be 3 of these strips. And again, you could shade in any 3 strips you want, really. You could go horizontal if you want to shade horizontally instead of vertically, but too late, I'm committed. I've got 3 tenths right there. Boom, boom, diddy, boom, boom, diddy, boom, 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 boom. Okay, cool. Now move over and do the hundredths. I got 6 of those. Now remember, each of these little squares is a hundredth, so I can go like 1, 2, 3, 4, 5, 6. That's 6 of those. Cool. Cool. Very cool. Very, very cool. But now I have to go 3 thousandths. And that means, and I'm going to use a different pen so we can see what we're trying to do here. That means, and it doesn't matter which square I use. Maybe I'll use this one. Cut that into 10 equal pieces. Yeah, it's going to get smudged. Cut that into 10 equal pieces and take 3 of those. So just try to imagine that that's about 3 tenths or something. Something like that. Okay? So you can make these decimal numbers as big as you want, or as long as you want, not as big as you want, but as long as you want. Just keep cutting things into tenths. So these are fractions. These really are fractions. They're just better fractions because you can type them into your calculator real easy, like, right? And that's what makes them so happy and popular and stuff like that. One more. I guess you would call this a mixed number. 20.47 means you've got 20 plus this fractional part of 0.7. So if each big box represents 1, then you're going to have 20 of these plus, and you can do this yourself, right? 47 of these hundredths, right? That's the tenths, that's the hundredths. I've got 47 hundredths. I might as well just kind of go like this. How's that look? 10, 20, 30, 40, 1, 2, 3, 4, 5, 6. Ooh, I gotta go another one. Almost messed that one up. And then shade it all in, shade it all in, yay. Shade it all in, shade it all in, yay. Shade it all in, shade it all in, yay. I like to do coloring on my iPad. Okay, good enough. Get these out of the way. They look like claw marks from a cat. Don't want that. All right, that's bringing back your memories of decimals, right? So that's really what they are. They just keep, well, they keep going smaller and smaller. Every time you add a new decimal place, you're taking that size thing and cutting it into 10 more equal pieces and so on. Next, what's a percent? Well, percents are nice. They're a lot easier to explain than decimals because the whole enchilada, pie, pizza, square, whatever it is you got, the whole is divided into 100 equal pieces, and that's where the sentence ends. You divide it into 100 equal pieces, so that's why this looks a lot like what we were doing on the previous page. I've got 100 equal squares here. Each little square is a percent, i.e. it's 1%. Each little square is 1% because there's 100 of them. The whole box has 100 equal pieces. Equal pieces, again with the equal. 100 equal pieces. So 3 of them, cool. There's 3 of them. I can do that. That wasn't hard. Okay, cool. That's what 3% looks like. Here's 33%. Now notice you can really just count off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of course, there's 10 in a strip, right? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yep. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There's 30%. And we want to get to 33, right? Okay, maybe I'll do these three, just to be weird. So, 33%. I have just X'd in 33%. 2.5%. Well, again, every one of these little boxes is a percent. So 2.5%. We can do that. 1, 2. That's 2. 0.5 would mean another half, right? So I guess maybe I will go with shading instead of X's here, so it looks a little better. And that's how you do that. You've seen things like this before. Have you ever wondered what they were? They look mysterious, right? Oh, they're not. 6 3/4%. So shade in 6 boxes. There's 6. So try to shade those in real quick. But not just 6 of them. 6 3/4 of them. So, okay, I'll shade in another 3/4 of a box. It doesn't particularly matter where. Maybe I'll do it. Where am I going to do it? Maybe I'll do it over here just to be very, very weird. Okay, so 3/4. That's 1, that's 2, that's supposed to be 3/4 that I'm shading in. That's what I'm trying to do. Anyway, so that would be 6 3/4% shaded. Cool. What else have I got? Oh, 217%. So when numbers are over 100%, it means you've got more than one whole enchilada, right? So 100% is a whole enchilada. 200% is 2 whole enchiladas. 2 of these enchiladas is 200%, right? Every whole is 100%. So I got 200% right there. If I have, well, I'd have to make 2 of these boxes. I'm just saying I've got 2 of them, right? And then another 17%, and you can do that. I can do that too. So I just shaded in, or X'd in 17 of those little percent boxes. 270%. Cool. Cool, cool, cool. All right, ready for a quiz? We're on page 4. This is the last one, folks. We're getting there. The question is, what's this stuff? And by stuff, I like blue. By stuff, I mean, what number is this? And what number is this? What number is being represented on these 2 diagrams? I mean, I suppose you could count and say, whoa, this is a whole bunch of tiles. 1, 2, 3 tiles. No, 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 no. Think of the big square as 1. So what number is shaded here? And what number is shaded here? So if you look at this one, if you remember that every strip has 10 in it, you've got 10, 20, 30, 40, 50 out of 100, right? So I think I'm just going to call that 50%. Cool. The thing was cut into 100 equal pieces. 50 of them are shaded. This represents 50%. i.e., this represents, now if we were doing decimals, right, we would be saying 50 over 100, which, well, we don't have to do it that way. 0.1, 0.2, 0.3, 0.4, 0.5. Look at every strip as a tenth. 0.50 as a decimal. As a fraction, you can tell just by looking at it. Doesn't that look like half? Looks like half to me. Or you could say it's 50 over 100, which eventually reduces to a half. So it's 0.50, it's 50%, it's 1/2, right? So these are, again, fractions, decimals, and percents. They're just 3 ways of expressing a quantity. Sometimes we like percents. A lot of people love their percents. Sometimes fractions are a little more easy to understand. Like it's easy for me to understand 1 in 200 than it is to understand 0.5%. I don't know why that is, but it is. And then 0.5. Some people like decimals because you can type them on your calculators. Okay, so we want to be able to go back and forth between all 3. Now, what about this one? You got these over here. You got this figured out. Well, if you count, you got 25. 25 of those are filled in. 25 out of 100 is 25%. i.e., the decimal form would be 0.1, 0.2, and then another, it'd be 0.25. If you look back 2 pages, that's how we did the decimals. i.e., give me a pen, i.e., 0.25, well, you could think of place value. 0.25 means you go out to the hundredths place, which means it's 25 over 100, and you reduce for a while, and you'll end up with a fourth. Doesn't that look like a fourth to you? Well, here's where the half is, right? Doesn't that look like half of the half? Half of a half is a fourth. So, yeah, it works. Get this out of here. Lobotomy. Okay. So now we get to the math class part, the real math class part. That was all kind of conceptual. Conceptual is really important to spend some time on the conceptual, because that's how you can start. That's how you remember the rules. You say, "Oh, I know why that rule works. That rule works because of this concept I have," and that's how you end up remembering rules. Just trying to memorize an English statement. You put this thing on that thing and you move it over there and then you blah, blah, blah. You know, that doesn't stick in your head very well. Maybe if you sing it. Yeah, if you sing it, it might. What I just say? You put this thing. Anyway, whatever. If you sing it, it might work, but it's better if you have like an idea, like, oh, I see what's going on there. I see what's going on there. So anyway, let's see what's going on here. I'm going to make some rules for ourselves here. So the 0.25, we want to make that into a percent, right? So I'm converting a decimal into a percent. Well, I'm just going to ask you to refer to this diagram that we were just playing with. We know that's 0.25, and we know it's 25%. You have different ways of knowing that. You know that 0.25 is 25%. Okay, so how do you get a rule out of that? Well, look at the 0.25 and look at the 25, and you'll say, I guess what I'm doing is I'm sliding the decimal 2 places. That's what I'm doing. Now, the 25%, again, that's the same as the 0.25. That's the answer. So if you want to take the percent off, it looks like you're going the other way 2 places with the decimal. Okay? Always 2 places. Here's the basic rule. Put it in green. You want to go, notice I'm in alphabetical order here, DP. DP, alphabetical order. Decimal to percent is always a double whap. Double whap, double play, double whammy, double. It's always a sliding of 2. Notice if you're trying to get from the decimal to the percent, you got to go to the right, don't you? Yeah, you do. Or if you want to get from a percent to a decimal, you got to go to the left, don't you? Just like we did here, right? Yeah. So I like that. You just put them in alphabetical order, DP. You remember that it's a double play, so to speak, to get back and forth. And then for the rest of your life, you make sure that you go 2 decimal places. 2. Always 2. Exactly 2. No matter what else in the world is happening, 2. Always 2. What'll happen is someone will see something like this, 0.0075%. They want to make it into a decimal, and they're like, oh my God, that's terrible. Look at all those zeros. Well, what you're supposed to do, according to this, to get from a percent to a decimal, is you would go this way. Well, that's what you got to do. I know it looks goofy. I know it looks goofy. That doesn't mean you should get it wrong on the test or something. It looks goofy, but that's what you do. Just think back to the 25% is 0.25. Yeah, you got to go to the left. Got to go to the left. So if you can remember the part about always go 2 no matter how funny it looks, then you always go 2. Always go 2. Always 2. Always 2. Okay, got it? 2. 2. Okay, 2. Next. Okay, I don't want red. Let's do this color again. Now let's go back and forth, percents and fractions. By the way, this is cool, right? Double play, that's all you need to know. And now you can go from decimals to percents. That's one rule down. Now we got some more to go. Percents to fractions, what do we do here? Well, I'm going to ask you to dig on something. Dig. You see this 100%? It's the same as 1, right? When you have one whole, you have 100%. So if 100% is the same as 1, and you can always multiply or divide by 1 without changing anything, really, right? So I'm just going to say 100% is the same as 1, and you can always and forever multiply or divide by 1, and everything is still good. If I take 6 and I multiply by 1, it's still 6. It works. Okay, so it's 1. So what I'm going to do here then, you can multiply or you can divide by 1, either way. So what I'm going to do here is switch colors. I got 40%, and what I'm trying to do is, I have a percent. I'm trying to get to a fraction, right? I want to make that a fraction or just a regular number. Not a decimal, but just a regular fraction, I guess. Number fraction, whatever you want to call it. So how am I going to use this 100%? Well, think of it this way. What I'd like to do is get that percent to sort of cancel off. So you put the 100% underneath. canceling the percent symbol. So it's 40 over 100, which will reduce to 4 over 10, which will reduce even further if you cancel 2's to 2/5. So 40% is actually 2/5. Okay, instant replay. What did I do? I took the 40% and I said, oh, I don't like the percent symbol there. I don't want that. So 100% is something I could just shove in anywhere. So I'm going to shove it right there. I'm going to shove it underneath. Why underneath? That way the percent symbols will cancel each other off, and I'll have a nice pure fraction. Pure fraction. 40 over 100. Reduce, reduce, reduce. You get 2/5. Now that's nifty. Now there's 3/8. It's a fraction. It doesn't have a percent on it, so I'm not going to be putting 100% on the bottom. In fact, what I'd like to do is put 100% on the top, so to speak. So what I'm going to do is, you can always divide by 1. You can always multiply by 1. I'm multiplying by 100% because that's always legal. So I get 3, put it over 1. It looks better when you have fractions. So 3 times 100% makes a 300% on the top. 8 times 1 makes an 8 on the bottom. Go get out your calculator. Do 300 divided by 8. And it will tell you that it's 37.5. And you've got a percent symbol here. Don't lose it. So it's 37.5%. So that's really all you got to do. Actually, geez, on the calculators these days, you could just directly say, hey, let's do it with a different kind of pen, right? You could always just do 3 divided by 8, because that's what a fraction is, and then times 100, and you get 37.5, and you say, well, really, you can't type the percent symbol in, but you got to remember that the percent symbol goes on there, because you're multiplying not by 100, you're multiplying by 100%. Okay, so multiply by 100%, divide by 100%, and then you'll be good going back and forth from percents to fractions. Now, 2 more to do, and this will clean it up. Clean it up? Yes, we're going to be clean about this. When you have a decimal and you want a fraction, okay, place value. Remember, decimals are decimal fractions. They're based on cutting things into tenths or hundredths or thousandths or whatever. And the place value tells you what you're cutting into. That would be the tenths place. That would be the hundredths place. We don't have any tenths, but we have 500ths. So actually, I could grab the tenths as well if I wanted to and call it like this. 0.5 in the hundredths place looks like this. 5 over 100, if you cancel 5's top and bottom, you're getting 1/20th. 0.05 is the same as 1/20th. 1 over 40, that's a decimal. I want to make it a percent. Okay. Or no, I don't. No, I don't. I'm over here. Fractions. I want to make it a decimal. I want to make it a decimal. Well, this is, if you got a calculator in your hand, this is easy as can be. You take the 1 and you cut it into 40 equal pieces, right? You've heard that way of expressing a fraction. The bottom is telling you to cut something into that many equal pieces. So 1 divided into 40 equal pieces, your calculator will tell you, lickety split, that is 0.025 as the decimal. If you want, you can make it a percent. Remember, you'd go this way to get to a percent. It'd be 2.5%. We don't have to do that now. So if you look at these 6 examples here, right, this is every possibility. Decimal to percent, decimal to fraction, fraction to percent, fraction to decimal, percent to, it's all there. You got 1 example of each. These are always what you can do. Sometimes people can try to make the numbers look a little weird, but this is what you do. This is what you do. You want to make a fraction into a decimal, top divided by bottom. You want to make a decimal into a fraction, read the place value. You want to make a percent into a fraction, put it over 100%, so the percents will cancel. You want to put a fraction into a percent, multiply by 100%. That way you get a percent in there. And then decimals and percents back and forth. That's the best thing in the world, because all you're doing is sliding your decimal back and forth 2 places. Just, what's the word? Discipline yourself. 2 places. 2. Only 2. Always 2. Only 2. Well, that's not bad. A 34-minute first lecture. Yeah, we can go with that. So the homework's waiting for you, and then we're going to do another lecture right away. Right? Okay,